Anybody there? Anybody there? Hello, anybody there?
السلام عليكم دكتور.
عليكم السلام. البقية راح يجوا؟
ايوه.
طيب نعطيهم دقيقة. هاي ثريا اجت. البقية جايين؟
دكتور.
السلام عليكم.
عليكم السلام ورحمة الله، كيف حالكم؟
الله يسعدك، الحمد لله. أنت كيف صحتك دكتور؟
والله بألف خير بألف خير. يلا متأخرين الليلة بس عادي، سهرة.
مش مشكلة.
عادي، مش مشكلة، في سبيل العلم إن شاء الله خير.
يا الله إن شاء الله. مبلوش أنا كثير فبحاول أنه أقدم بس ما زبطت معي.
الله يعينك دكتور ويعطيك العافية.
على الجميع إن شاء الله.
إن شاء الله.
إبراهيم بعده ما إجا ولا ميس؟
لا لسه اثنيناتهم ما يجوا، بس يمكن في مشكلة بالاتصال أو هيك شيء.
لا في الوقت هذا عادة بتهون، يعني مش لما نتأخر هيك ما فيش مشكلة، لأنه بشوف سرعته إلا لما كيف أنا أشبك مع السيستم بشوفه عادي.
راح؟
السيستم بشوفه عادي، يعني لما بالأوقات هذه ما عمروش تمشكلت في النظام. في أوقات معينة بعد الظهر وهيك في كثير ناس عليه، بصير عليه ضغط، مرات بصير مشكلة، بس بأواخر الليل هيك ما عمريش أنا لقيت مشكلة. طب احكوا معهم أو ابعثوا لهم شيء، أو ابعثوا لهم.
نبعث لهم على الجروب.
الرقم بعثوا لهم إياه؟
هي ببعث لهم إياه هسه.
ماشي.
هي بعثت لهم إياه، بس خليه إن شاء الله يوصل.
يلا مش مشكلة. هاي ميس اجت. ميس وصلتي؟ ميس، مع انه المفروض تكون هلا معنا ميس.
السلام عليكم.
عليكم السلام ورحمة الله وبركاته. بقي إبراهيم. العادة إبراهيم من أول من أوائل المتصلين بكم. اليوم عوانطجي.
شايف؟
رد عليكم إشي، حكى إنه بيحاول؟
والله لسه دكتور، بس أتوقع إنه بيحاول، لأنه هو كمان كان يستنى، بيحكي إنه الدكتور تأخر شوي بس راح يرجع يعني يعطينا المحاضرة.
أنا حكيت لكم، ما أعطيتكم وقت محدد، بس إنه قلت تقريبا يعني، بس لأنه لحتى تصير أموري تمام.
عادي دكتور، مش مشكلة.
يلا بنعطيه نص دقيقة، إذا ما إجا he can join يعني. ما بعث شيء ولا حكى؟ ها؟
لا والله أنا ما في، يعني ما وصلت لسه عندنا جروب فيه.
طيب I think we will start. He will join whenever he arrives. You will find out that between the two lectures, especially in your PDF, there will be overlap. And this slide and two more at least, maybe in your other lectures they were. I stopped here last time. So I put also this one in this lecture, but this one and two more, you will find them also in the other lecture. So it's okay. Don't be confused. So that because there is so much continuation and connection between them, I want to start from somewhere we stop so we can see it, then we can continue on. So don't be confused. كلهم التايتلز تبعهم clear.
Don't be confused. كلهم التايتلز تبعهم.
اوكي هي ابراهيم اجاب بخربط. ابراهيم صرت معنا؟ ابراهيم.
هلا دكتور كيفك؟
هلا مرحبا. Okay.
الله يعطيك العافية.
هلا الله يعافيك. Okay, so everybody's here. What I was saying, there will be an overlap in your PDF files between the two lectures, and I did that on purpose. So this slide we're looking at now is also included in your last lecture, lecture G9. Kaman, the next two are also included in the other one, but that's fine. It's just simply because I want to start where there is continuation. So if you remember, the last thing we talked about was how we trying to simplify things by reducing the number of variables. And we saw that the relationship between the bicarbonate ion and H2CO3, the carbonic acid, the ratio is very large. So that means the bicarbonate is way much larger than the bicarbonate, so the carbonic acid, sorry. So we can ignore this at this time. I say again and again, at the end you will see that we will calculate all the variables, but we will try to do what can help us to minimize the number of variables so we can reduce them. Okay. So this leaves after the simplification. If you remember, we said that every species, we have this already, calcium times carbonate, we know that. And we have these 2, 3, 4. This, we already know this, right? This is nothing new. All of them we know.
Yeah.
Okay, now, if you see this one, calcium, we said, if you remember last time, we agreed and we said that for every species for calcium, for every ion, there has to be a species of carbonate, or the other way, for every species that contains a carbon atom, there has to be a calcium ion. So you remember there used to be here plus H2CO3. Now we removed H2CO3 because it is so small. We agreed already compared to the bicarbonate, we already proved that it's so small. So it's not included in this. So this is a new equation. And also remember here, we have what did we call this one, if you remember? Or you didn't look at any? I'm sure you're probably all busy with other things, right? You remember what did we call this equation? Yeah, it starts with N in neutrality, because the positive charges have to equal the negative charges. And remember, we explained why we multiply the calcium by 2, why we multiply the carbonate by 2, and so on.
حتى يصير عندنا neutral solution.
Yeah, the neutrality, that means the charges. The charges of the positive charges have to equal the negative charges to have neutrality. This one, the matching between the calcium and the species that contain carbon. So this one we simplified, this one is the same as it was. Multiplying, remember, in chemistry, just like mathematics, you can multiply equations and add them and subtract them exactly like you do in math, as long as you keep the left side and the right side underneath each other.
دكتور بس هاي المعادلة 6 ليش شالوا منها الاتش؟ الاتش هون المعادلة رقم 6 هاي ليش شالوا الاتش؟ مش كان في عندنا اتش هيدروجين؟
ما هو الاتش very good question. يعني في ناس somebody is paying attention. لما نقول 10 to the minus 8 هلا compared to the OH it's nothing. فأي شيء so small we ignore.
Okay.
Compared to the calcium, which is in the concentrations in moles per liter, millimoles per liter. When you talk about 10 to the minus 8 moles per liter, it's extremely small. فلما خاصة بالجمع لما نجمع هلا if you multiply you can do that. Remember, small numbers you can ignore them when you add and subtract because their value is so small it's not going to change anything. But if you multiply, you can do that.
Okay.
Okay. So multiply equation 5 by 2 and subtracting from 6. So you multiply this by 2. مشان يصير عندنا هنا 2 and 2. Okay, so that you get rid of certain things. And then you subtract it from 6. Subtract this after you multiply it by 2. فبصير عندنا 2 calcium equals 2 carbonate plus 2 bicarbonate. And then you put it underneath this one and subtract. So we get a new HCO3 minus equals OH minus. That's a new equation. Okay, this is number 7. The easiest method of substitution is perhaps to express all equilibria in terms of hydrogen and substituting into 5 into this equation. So we will try to make everything in terms of hydrogen. We will simple. Again, this is mostly mathematical manipulation. So if we start with hydrogen times hydroxide equal 10 to the minus 14, that's Kw of water, remember? So OH in terms of hydrogen, 10 to the minus 14 over hydrogen. Simple, right? في مشكلة؟
لا تمام.
Simple math. Substituting from 7, HCO3 minus the bicarbonate over equals 10 to the minus 14 over H. Remember, equals OH. So the OH, we put its value in terms of hydrogen because we're trying to find everything in terms of hydrogen.
طب ليش ما حطوا مثلا قيمة الهيدروجين هي معنا مثلا احنا طلعناها الافتراضية ليش ما حطوها هون؟
هلا remember we are simplifying, but the real value أصلا what we want is really to find the real H. And we go back to the equations to solve for H and for all of them. We simplified at a certain stage بس مش حكيت لكم مش معناه نرميهم. So we go back to the original equations and we try to put them all in terms of hydrogen regardless of what its value. But ما بنقدر نرميه. رميناه بالجمع وبالطرح حكيت لكم to make things simple. بس مش الvalue تبعه راحت. ما هو it's the pH. We are trying to find the pH of a calcareous soil. Okay. Okay. So now we have the hydroxide OH in terms of hydrogen, and we have the bicarbonate in terms of also of hydrogen. Substituting 8 into 3, this, which is the value of the bicarbonate. So instead of the bicarbonate, بنحط هلا قيمتها in terms of hydrogen, and then we substitute after the substitution راح تشوفوا انه بيطلع لنا the carbonate in terms of hydrogen also. Okay. هذا كله جمع وطرح powers. That's all. Simple math. راح تشوفوا لما تضربوهم ببعض وتطلع كله بيطلع عندكم الارقام هذه 100%. Substituting 9 into 1 نرجع calcium equals 10 to the 16 H plus square. A new equation 10. Finally, by using مثل ما حكيت لكم, the best way to study this is to print it and you put each slide side by side. Whenever we talk about an equation, bring it back, look at it, and do all subtraction by your hand. Do this, have a pen and or pencil and paper with you. This is the only way you can learn it, okay? because back and forth it's very confusing, but it's very simple, very logical if you have them all side by side. Okay. Finally, by using 8, 9, and 10 into 5, we go back. Remember, we said we will change everything in terms of hydrogen and substitute in 5. That's what we're doing. 10 to the 16, 10 to the 16, H plus square equals 10 to the minus 24.3 over H plus square plus 10 to the minus 14 over H plus. Again, you learned in math. Sometimes you multiply, you subtract, you divide by certain numbers to make things easier. Multiplying by H plus square نضرب الطرفين. اوكي حتى نتخلص من هون. اوكي نتخلص من الاشياء اللي فيها جمع وطرح. فهون multiplying it becomes 10 to the 16 H plus لما نضربها بسكوير بصير H plus to the power 4. اوكي minus 10 to the minus 14 H لما نضرب ب H square H بصير فوق وهذه بتروح, you know, simple. So now you have an equation with hydrogen only. 10 to the 16 H plus to the power 4 minus 10 to the minus 14 times H plus equals 10 to the minus 24.3. So this is our final equation. Simple. The easiest method of solution is by trial and error. Always, this type of things, the only way that you can solve them is by trial and error. You cannot find easy solution for these powers and things. So you can start with our H. Remember, we assumed H to 10 to the minus 8. You can start saying, okay, well, that's the value. And then you will see, when you add these, did we come close to this number or no? Are we far from it? And you keep on changing. So it yields, that means the solution we found from the trial and error, H plus equals 10 to the minus 9.95. That means pH 9.95. Remember what we assumed? We said H 10 to the minus 8. We knew it was very basic. And so it's actually much smaller than even what we assumed. We assumed 10 to the minus 8, and now it's much less. So the pH is much higher, which means hydrogen is much less than that. Back substitution into the equations, remember to find the values of all of them in terms of hydrogen. Now we know the value of hydrogen. We go back to each one of the ones in terms of hydrogen, and we solve for them. So calcium, 10 to the minus 3.9, carbonate, 10 to the minus 4.4, bicarbonate, and OH, 10 to the minus 4.05. So now we solved for all the variables we want by simplifying at the beginning, but later we expressed everything in terms of 1. And okay, شو إبراهيم طلع ورجع, I don't know, somehow or another. Simple math, فيها confusion شوي, بس it's very interesting. How do you find it? Mind staring? كيف شايفين الأمور؟ مليحة؟ Hello?
دكتور بس لأنه شو اسمه فصل وفات وطلع مش عارف.
في ناس عم بيطلعوا وبفوتوا، شو القصة يعني، في مشاكل؟
الكونكشن أبصر شو مالهم، فجأة بيطلع فجأة بفوت.
هلا مين معنا؟
هلا لحظة نشوف. بس أنا
بس أنت الوحيدة، الباقي كلهم أنا شفت إبراهيم أدمت أجين، معناه إنه فصل.
فصل.
كأنهم على كل حال يعني we can't stop too long يعني we will continue. بس أنت اللي بيسألوا you can explain والمحاضرة واضحة يعني I think they will understand most of what we're talking about.
وهي راح تنزل على اليوتيوب اوريدي صح؟
اكيد المحاضرات كلها احطها على اليوتيوب.
خلاص تمام.
Okay, we will continue on. Hello.
معك.
Yeah, I'm بحاول البديل. They are trying. I think everybody is now back in.
دكتور بس احنا مش ما كناش هون، انا ما شفتش الاشياء.
دكتور
ضعتوا ولا النظام فصل معكم؟
لا النظام فصل معنا.
في اصواتكم مش صح، يعني ما عم بسمع شو بتحكوا.
انا النظام عندي فصل، طلعني من لحالي هيك.
لحالك؟ النظام طلعك لحاله؟ يا عيب ويا عيب وبيعكيفوا. طيب هلا الكل معنا؟
موجود انا بالنسبه لي.
الكل
دكتور
الصوت عم بقطع، بس قربوا على الميكروفون قد ما تقدروا. Okay, so we solved the first case and we said that the first case is really only solution of the solubility of calcium carbonate. What we are really interested in is this case. This is where we are interested in. That's what happens in nature. That's what happens in calcareous soil. So we took the first case to practice on and see how we do it. And then this should be much easier because we already know the tricks we have been doing. So this is case 2, the carbonate equilibria. Case 2. Case 2, we have calcium carbonate aqueous system with externally fixed pressure of CO2. That's the CO2 we assume in the soil system, inside the soil, in contact with the carbonate that's in the soil system, and which is at a natural way. طبعا CO2 is never fixed, but of course you can't solve things for changing pressure of CO2. So we always assume close to what is reality. And so we will assume it's a fixed pressure of CO2. The first 5 equations applies to this case. If you go back to case 1, because these are the equilibria constant, they are constant. They don't change. Whether you have CO2 or you don't, it doesn't make any difference. They are the same. However, equation 1D, again, like I said, you print out the lectures if you have a chance and put them next to you, and that you look back at what was 1D, put it next to you and see what it is and how we're talking about. Is not valid because carbonate species are derived from the external CO2 sources as well as from the calcite. Remember at the beginning, we said calcium species, it has to be matched with every species that contains carbon because they all come from calcium carbonate. In this particular case, CO2 is another source of carbon. So it dissolves in water, so it gives us also carbon species. So we cannot say they all came matched with calcium. This does not work. Equation 1E expressing electrical neutrality does hold. طبعا this does not change. You have to have neutrality regardless where these ions come from. These, where the ions come from. Here, after you have ions, they have charges. The charges have to be equal. Positive equals negative. It doesn't make any difference. As a substitute for equation 1D that we lost, we can use PCO2 equals K. That is the partial pressure of CO2 which is in the soil system, which we said will, for our practical purposes, we'll assume it's fixed. Okay, so we go back from equation 5, H2CO3, these already we have them. Remember all these equations in the first, second slide that we talked about in case 1. So H2CO3 over PCO2, and remember I've told you, when we talk about gases, this is a gas, CO2. This is, although it's gaseous, but remember, it can also exist in aqueous system. So even though eventually it's aqueous and it goes gaseous, it will leave the system, it will disintegrate, but CO2 is the real gas. So we cannot have concentration for it or activity. the concentration is its partial pressure. So this is equivalent to putting activity like we do for others. So that's why we say P, CO2, that's its concentration. Okay, so equals K of CO2, which is equals 10 to the minus 1.47. We already knew that. So H2CO, solve for H2CO3, you multiply this by this, 10 to the minus 1.47 times the pressure, the partial pressure of CO2. كل موجود معي موجود هلا؟
نعم
موجودين
دكتور.
موجودين.
الكل موجود؟ الحمد لله. At a specified PCO2, equations 1, 2, 3, 4, the one, remember we said these are the same as from the first case on the second slide, and 1E and 6 describe the system. Remember, you need the number of equations have to be the same number as the variables. As a specific example, let's solve for equilibrium with the atmosphere in which PCO2 approximately 10 to the minus 3.5. Where does this one come from? If you look at CO2 in our atmosphere, it's approximately 0.03%. That's the amount of CO2 in the atmosphere. So we're assuming it's similar. If you change it to log, it will get you to this value. Okay, so from equation 6, H2CO3 equals 10 to the minus 1.47 times 10 to the minus 3.5, so equals 10 to the minus 4.97. Substituting so as to express equations 1E in terms of hydrogen. Again, remember, our policy was to express everything in one variable, and we choose hydrogen. The hydrogen is the one we're going to solve for anyway, and assuming as a first approximation that gamma of I equals 1. Like we did remember earlier, same thing. Gamma, so by that means we're assuming activity equals concentration. So we have the hydrogen times bicarbonate equals 10 to the minus 6.4 times 10 to the minus 4.97. The bicarbonate, again, if you go back to the equations in terms of hydrogen, all of these in terms of hydrogen, we're substituting. CO3 equals this times the bicarbonate over hydrogen equals this. So again, in terms of hydrogen. And OH, we know that already, 10 to the minus 14 kW of water over hydrogen. Then calcium equals 10 to the minus 8.3 over carbonate equals 10 to the minus 13.37 times hydrogen squared. Substituting the above values in the electrical neutrality equation, which is fixed, we just saw that. So these values, we're substituting them, all of them, multiplying through by hydrogen squared like we did before, and putting all numbers in powers of 10. You have to change them to power 10 so that we can manipulate them easily. So we have a new equation, 10 to the 13.67, okay, to the power 4, and this hydrogen cube, and so on. Collecting terms. You collect terms if they are equal, like this is hydrogen alone. This is hydrogen alone. So the ones that are hydrogen alone, of course, these are similar items. You can add them together. To the power 4, no. To power 3, no, it has to stay the same. You collect only the things that have the same power. So we end up with this equation, and again, we solve pi by trial and error, and we obtain the value of hydrogen equals H plus equals 10 to the minus 8.4. That is the real value. Most of the time you have learned always calcareous soils are alkaline. But how alkaline? What is the real pH? If we have the CO2 value, the value we gave, which can vary a little bit here, up and there, but which is very close to what reality is. If you don't have any other interferences, no salts, no other the pH of a calcareous soil will be 8.4. Hydrogen will be 10 to the minus 8.4, or the pH will be 8.4. Now you find calcareous soils with higher than that, there will be effect of sodium comes in. If you have salts, that will depress the pH, and you can have calcareous soil with pH even 7, 7.5. So now you should know why we have the variation. But the real value, if you have pure system, no other effect, the pH will be around this value, the pH of a pure calcite. Of course, the calcite also, we're assuming here pure calcite. In nature, it might not be pure. It could be, there could be substitution of magnesium or something in the structure of the, so the case will be different, okay? So then we solve for all of them. So now we have calcium concentration 10 to the 3.4, carbonate 10 to the minus 4.9, bicarbonate 10 to the power minus 3, the hydroxide 10 to the minus 5.6. Of course, you add this to this, remember, they have to be 14, and then the carbonic acid 10 to the minus 4. Therefore, the pH of a system containing calcium carbonate in water in equilibrium with the atmosphere is 8.4, and that's really what we wanted to get at. That's what I want you to see, how we arrive at things like that mathematically and chemically, and we know that's the way it should be. Okay, so I think that's the last lecture we finished, and if you have any reason for us to talk about anything, we can. We can have a discussion about your presentation soon if you want to. You still with me?
Yes, with you. يعطيك العافية.
بدنا دكتور.
Allah يعافيكم. So we can communicate and have some kind of discussion about your presentation later, okay?
إن شاء الله.
تمام دكتور.
تصبحون على خير.
دكتور ما قصرت.
أنت بألف خير دكتور.
يعطيك
الله
العافية.
معكم. مع السلامة.
دكتور استفسار ممكن بعد اذنك؟
نعم؟
استفسار بعد اذنك.
ماشي تفضل السريع لأنه هذا كله راح يكون بالمحاضرة. ماشي.
اوكي هسه بس توزيع العلامات خلال الفصل كيف راح يكون زي ما هو على خدمات الطالب؟
التوزيع راح نحكي فيه. أنا ما شفت كيف حطوهم توزيعات جديدة.
هم نزلوا عدة قوانين بس عادي أتوقع يعني الأمر بالنهاية يرجع للأستاذ.
لا أنا ما ببلشش فيهم بس بنحاول نتعايش معهم. بس أنا بالأمور خاصة بالنسبة للجراduate students I never do what they say بس إحنا بنحطه بالطريقة اللي هم بدهم إياها.
خلص أبارك.
راح نحكي في هذا بعدين. أوكي.
إن شاء الله إن شاء الله.
يلا تصبحون على خير.
هلا دكتور الله معك.
مع السلامة.
الله معك.